Alright, you guys, in order to solve this equation right here, what we want to do is first realize that's a 2/3. It's a 2/3 power. And to solve this, the first step, as you can see in red, is we divided both sides by 5. So we get this to be a 4. And so we get the radical or fractional power part all by itself. So we now have the green. Now, to finish solving this, you could make this a cube root with an x squared, make it a radical. It's easier just to take a power of both sides of the reciprocal. Since the power is 2/3, if I take the power of the reciprocal, which is flip the fraction, that becomes 2 times 3 is 6, and 3 times 2 is 6. 6 over 6 is 1. So basically the power drops off and you simply have x plus 1. So again, you're powering both sides by the reciprocal of this power. Reciprocal is flip it, flip the fraction. And over here we took the 3 over 2 power as well. Now, this side again was x plus 1. This side we have to simplify. And what I notice here real quick is I notice 4 is 2 squared. So, oh, 2 squared, cool. Alright, and the reason I did that is, next step is, well, if I know as 4 is 2 squared, well, can I multiply 2 times 3 over 2? When I multiply 2 times 3 over 2, that becomes 6 over 2, which is 3. So what I now get this breaks down all the way to 2 cubed. Because 2 times 3 over 2 is 6 over 2. 6 over 2 is 3, so I now have a third power. Over here still stays x plus 1. This little simplification here is a little tricky. Now, I want to now solve this. So I'm going to get x by itself, so minus the 1 over. When I minus the 1 over, I now have negative 1 plus 8. Where did 8 come from? Well, 2 cubed. 2 times 2 times 2 is 8. And negative 1 plus 8 is 7. So that is my answer. Now, the problem we have here is you now need to be very careful because you now need to check your answer because 7 might not work, or it might work. We'll see. Let's check just to see what our solution says. So what we have here is I now, taking 7, put it into the original function. That's the original function we had, except x is now 7. So I replace the x of the original function with 7. So 7 plus 1 is 8. Alright, now 5 times 8 to the 2/3 power equals 20. Now that might be a little confusing, so hopefully you know that 8, if you think about that, is 2 cubed. Because the goal is to get rid of, see this cube right here, this 3 in the denominator? That's a trick. Whatever that is what you want this to be a power of. So you're hoping that this is a power of 3. And it is. It's 2/3. 2 to the 3rd power. All that stated, looking for this and knowing what kind of power it is a difficult thing. Anyways, from there, what I'm going to do is I'm going to take 3 times 2, which is 6. 6 divided by 3 is 2. So this whole thing becomes 2 squared. Again, because you have 6 divided by 3 is 2. Then you have 2 squared is 4, and 5 times 4 equals 20. So we're good. So 7 is a solution. The check worked out. Now, instead of doing this with fractional powers, you could have also written this as the cube root of 8 squared. And the cube root of 8 is 2, which you get 2 squared. So it all depends on how you want to rewrite these to plug them in. It can be a little tricky. But 7 is, for sure, an answer to this problem. Alright, let's go look here at problem 2. So for problem 2 here, I have this equation. I need to get the square root by itself before I start trying to solve anything. So what I'm going to do is I got to get rid of this 3 by minusing the 3 over. That just becomes x minus 3. I still have this negative in front, so to get rid of that negative, I'm going to divide both sides, as you can tell in red, by negative 1. When I divide this by negative 1, hopefully you realize that will become a negative x and a positive 3 when you divide by negative 1. It basically switches the signs. So I now have the square root of 2x minus 3 and negative x plus 3. To get rid of a square root, we square both sides. When I square a square root, I get 2x minus 3. Now I have a squared here. Squared means times itself, so I have 2 of them. So I now have to FOIL this. So negative x times negative x is x squared. Negative x times 3 is negative 3x. 3 times negative x is negative 3x. So a negative 3x and negative 3x is a negative 6x. And 3 times 3 is 9. Now again, where to get negative 6x? Negative x times 3 is negative 3x. 3 times negative x is negative 3x. I combine those negative 3x's to get negative 6x. So that's the right side when I FOIL this. The left side stays the same. But now to solve this, since I have a quadratic, I need to move this stuff over to the right side. So I'm going to minus 2x over right here. And I'm going to add 3 over right here. When I do that, this 2 add up to negative 8, and these 2 add up to positive 12, leaving you a 0 on the right side. Let's push this up. Okay, this is a little bit longer problem, as you can kind of tell. So, we got this. I can now factor to solve it. I put the 12 on top, the negative 8 on bottom. 12 on top, negative 8 on bottom. When I factor, I notice negative 6 times negative 2 is positive 12, and negative 6 plus negative 2 is negative 8. So I factored it as x minus 6, x minus 2. Those are my factors. To solve it, I set each factor equal to 0 and solve them. So this would solve to be 2. This would solve to be 6. Now, the reason this is crossed out is it's going to be an extraneous solution. You'll see here in a second. Because we have to remember to check both answers, and that's what this is down here is. This is my check. Don't forget to check. We got 2 answers. One of them has an issue. So if we go to the original function, it's all right here, except the x's are now 6. See the red? That was an x. That was an x from the original function. So the x is now a 6, and the x is a 6. 2 times 6 is 12. 12 minus 3 is 9. The square root of 9 is 3. Is 3 minus 3 go to 6? No, it's not. So I cross that answer out. It is not a solution. It's called an extraneous solution. So 6 does not count. Now we also plug in 2. So I plugged in 2. See how 2 replaces the x here and here. See, just it's a 2 instead of a 6 from above. Okay, so I plugged in 2. 2 times 2 is 4. 4 minus 3 is 1, so I get the square root of 1. All right. Now, you also get, that's the square root of 1, and the square root of 1 is 1, and 3 minus 1, that is 2, so we're good. So 2, yes, 2 is an answer, where 6 was not, so it only has one solution. Make sure you check for these weird situations that don't work. All right, let's go to the last one. Last problem. Alrighty. For this problem, I want to solve this equation right here. In order to solve, usually what you want to do is isolate the square roots. Since I have 2 square roots on one side, I don't want to deal with doing foiling. Doing all sorts of weird stuff here. Actually, it wouldn't be foiling, but it would if you squared it. Anyways, what I want to do here, instead, I think the easiest process would be to move this over. So since that's a minus there, I'm going to add it over. That's gone. I now have the square root of 4x minus 2, over here, and the square root of 2x plus 6 over here. So once I moved it over, now, as you can tell, I'm squaring both sides. All right? I'm squaring both sides to get rid of the square roots. That's just kind of the undoer of square roots is squareds. If these were cube roots, you'd be cubing both sides. It just depends on what you're dealing with. So, to solve this, I now have 4x minus 2 and 2x plus 6, and it's a very easy solve. Alright, to very easy solve this, I minus the 2x this way, I added the 2 this way, so that I now have 4 minus 2x is 2x, and 6 plus 2 is 8. I'm just doing basic solving. I just did 2 steps at once. Again, I moved this over here, and I moved this over here. Now I have 2x equals 8. I divide both sides by 2, and I get 4. But I have to check this solution. To check this solution, I am going to put in 4 there and there. So when I put in 4, 4 times 4 is 16, minus 2. Put in 4 here, 2 times 4 is 8, plus 6. And as you look at that, hopefully you can see that as you move that up, hopefully you can see right here that this is the square root of 14, and so is this. And when you take the square root of 14 minus the square root of 14, you do get 0. So 4 actually is a solution. It's not extraneous. It does work. So please remember to check for extraneous solutions. They're really important.